Now today we are going to discuss about the alternative energy. Alternative energy. So battery energy storage system. You know what? Solar Energy Corporation of India Limited has successfully commissioned India's largest battery energy storage system in Chhattisgarh. So the battery energy storage system, and that system is in Chhattisgarh. The commissioned storage energy using the solar energy, and they will use the solar energy in this. Ministry of New and Renewable Energy is collaborated with this scheme. SECI is also working with the Ministry of New and Renewable Energy. Earlier, Union Cabinet has approved the scheme. Viability gave funding for the development of this. So there is a viability gave funding. Viability gave funding is also associated with this scheme. So first is electrical energy storage. So mechanical energy. In mechanical energy, there is a pump, the hydro, flywheel, and the compressed air. And in electrochemical energy, there is a secondary battery. Secondary battery, lead acid, and nickel cadmium battery, nickel cadmium, and the lead acid battery. Secondary batteries, there is a flow of the battery. Electrical battery, there is a double layer capacitor is there. So double layered capacitor is there, and the superconducting magnetic energy is also there. And there is a magnetic energy. Chemical battery, there is a hydrogen fuel cell, and thermal energy, there is a sensible heat storage. Heat storage and hydrogen fuel cell. The fuel cell is there, that was hydrogen. Now about the battery energy storage system, the catalyzing under the electrochemical storage system, the uses a different electrochemical reactions. So this can be used independent of as a part of power system infra various level in the generation, transmission, and the distribution. Standards battery consisted of the pair of the plate electrode and in the electrolyte. Electrodes are separated by the non-conducting material. So some batteries are there. One is the lead acid battery, nickel cadmium, lithium ion battery, and the sodium sulfur battery. Flow battery uses the tank of electrolyte and a member of the control the flow of electrons. So they use the electrolyte and pumps for control the electrolyte flow of electrolyte. So there is a redox flow battery. One is the redox flow battery, second is the hybrid flow battery. Key highlights of the scheme is there. Advises the development of 4000 megawatt project. Financial support, 40% of the capital cost is viability gave funding, that was a 40% of the cost will be in this. It is provided to support the infra project and economically justified but fall the financial viability. So this is for the infra projects, and there is a viability gap funding economical just scheme target to achieve the leveraging cost of storage, and this is will make the stored renewable energy as a viable option to manage the peak power demand. So it will store the renewable energy. So renewable energy will be stored, and total cost of this divided into energy it is projected to provide over the course of useful life. A minimum 85% project capacity will be made available for the discom. So discoms, there is 85% of the capacity, and the ministry of power is working with this. Ministry of power is working with this. Now the lithium ion battery. So lithium ion battery is a noble laureate of co-inventor lithium ion battery, that was a John Bannister Goodenough, and a rechargeable battery in which lithium ion moves from the negative electrode to positive electrode during the discharge. Material used in this included the lithium cobalt oxide, lithium manganese oxide, electrical lithium iron phosphate. Goodenough developed the lithium battery for the cathode and cobalt oxide. So they use the cathode of cobalt oxide. So cobalt oxide and the cathode. So lithium ion battery use ether as a class of the organic compound in the electrolyte. So they are using the ether as a electrolyte, and solid state lithium battery, that is potential energy density. A solid state battery use the solid electrolyte, not liquid electrolyte. Lightweight, this is lightweight and high energy density, have a 5000 cycle or more compared to the 400 cycle in the lead acid battery, and required low maintenance, low self-discharging rate, no memory effect, low maintenance cost, and low discharging rates. So memory effect, repeated partial charge cycle can cause the battery to remember a lowest capacity. What is the disadvantage? High price and tendency to overheat can lead to the thermal runaway and combustion also. Other battery system in the news: advanced chemical cell battery. Ministry of Heavy Industry and announced the rebidding of this under the PLI scheme. National Program on Advanced Chemical Cell Battery Storage. A new generation of the advanced storage technology and store energy either in the electrochemical or the chemical energy. So that was the advanced chemical battery, and that battery store the energy in the electrochemical or the chemical energy, and this is comes under the Ministry of Heavy Industry, and there is a rebidding of the advanced chemical cell battery, and that was comes under the Ministry of Heavy Industry. Now next is the biodegradable paper supercapacitor. So Gujarat Energy Research Management Institute developed the paper based supercapacitor. So this is the supercapacitor, and that is the paper based. So thinnest, lightweight, and the biodegradable in nature. It is thinnest, lightweight, and biodegradable in nature. It is electrochemical charge storage device, and it has last charging discharging cycle, high power density, and the longer life cycle, and developed for the seaweed, marine macroalgae. This is developed for the seaweed. Now next is gravity battery. A gravity battery involves the lifting and the lowering heavy weight, and this when there is plenty of the green energy, the battery use the power to lift a heavy weight either into the air or into the deep shaft. When electricity demand pick up, the block are lowest one by one, and the releasing the kinetic energy. So this sodium ion battery. Now next one is the sodium ion battery, and this sodium ion as a charge carries the store release the electrical energy, and this currently evolve the viable substitute the lithium ion battery due to low cost and natural abundance of sodium. And sodium ion battery, that is the low cost battery, and there is a abundance of the sodium, uh, that's why significance is wider temperature tolerance, can even be stored and transported at zero voltage state, and it can store the zero voltage state also. Now next question, next is modular reactors. What are about the reactors? So China launched the world's first fourth generation nuclear reactor. It uses small modular reactor as a design. So fourth generation, and fourth generation reactor is a gas like helium for the cooling, unlike the conventional power plants that use the pressurized water. So in the fourth generation reactor, we are using the helium as a cooling agent rather than the use the pressurized water. So these are advanced nuclear reactor power generation capacity ranging 30 megawatt to 300 plus megawatt. Physically a fraction of the size of the conventional nuclear power, and that was system and the component to factory assembled and transferred as a unit of location. Reactor is the HEMS nuclear harness the nuclear fission. So it will harness the nuclear fission reaction. So what type of the small modular reactor? First is land based water cooled. Water cooled are the different configuration of the light water and technology. Marine based water, this can be achieved in the form of using the installed ship. High temperature gas cooled, that is employed in several industries and cogeneration. Liquid metal cooled fast neutron spectrum, and utilize the diverse coolant option and the helium, sodium, lead bismuth. Next is molten salt reactor. These technology is the long fuel cycle, several years, and options are online refueling. That is the salt reactor, and there is the option of the online refueling. Next is the micro reactor. Different types of the coolants and the light water, helium, molten salt, and liquid metal. It can be used in the micro reactor. So this adaptable, scalable, longer refueling interval, and only need to refuel every these 2 7 years. And compact design, passive safety features are also there to shut down the cool and reactor under the abnormal circumstances. So economically adaptability to allow the cone generation and the supply heat for manufacturing. International Nuclear Liability Convention, Vienna Convention, that was civil liability nuclear damage. Convention on Supplementary Compensation Nuclear Damage Act. Paris Convention, that was third party liability for the nuclear energy, and the joint protocol relating to the Vienna Convention and Paris, and Brussels Supplementary Convention for which is related to the Paris Convention. So these all conventions are related to the nuclear liability conventions. Net energy gain. US scientists achieved the net energy gain for second time in the nuclear fusion reaction. So they got the net energy gain in the nuclear fusion reaction, and there is a this is the fission. In fission, when two large atom is split into the smaller one, so they can be uranium or plutonium and use a nuclear fuel. And fusion is in the sun energy, like join two or more lighter atoms, and this can be hydrogen or helium. Okay, so process in which two light atom nucleus combine to form a single heavier one of releasing massive amount of energy occur in the state of matter called the plasma hot charged gas and made by positive ions and free moving electron. So two positive nuclei have to come closer and they repel each other. This phenomena is called the Colombo barrier. Column, this is known as column barriers. Column barrier, and to overcoming this barrier, massive energy is required. So this energy is presently more than the energy generated from the fusion reaction. So nuclear fusion is a clean and safe power. 1 kg of the fusion provide much energy as a 10 million kilogram of the fossil fuel. So hydrogen is abundance we have, so we can use the nuclear fusion for generating the energy. About the net energy gain, this critical for the commercial fusion power implies the nuclear fusion process more energy than other process. So India is part of the International Thermonuclear Experiment ITER project to demonstrate the nuclear fusion reaction. India has also constructed the indigenous tokamak Aditya and the semi-indigenous steady superconducting tokamak. So India is also part of the tokamak Aditya and semi-indigenous steady state superconducting tokamak. So about this aim, they demonstrate the nuclear fusion for the clean energy. So we need a clean energy. Okay, and located France as a collaboration with the China, US, India, UK, and Korea and the Russia and US. So aim to build the world largest tokamak as a magnetic fusion device designed to tape the potential fusion energy. Tokamak operates as a principle that power the sun and the star, and it can power the sun and the stars. So now Julius Robert Oppenheimer, he was the renowned American physician and played a key role success of the Manhattan Project. The Manhattan Project, and this is name is the American led effort to develop the functional atomic vehicle. He represented the creation of first nuclear bomb. So first nuclear bomb was from the Julius Robert Oppenheimer, and he is often known as the father of the atomic bomb. He is also worked for the fast neutron physics, and later he actively opposed the nuclear weapon. But in the starting phase, he was proposing the nuclear weapon, so name was the Julius Robert. Got the name, that was the Julius and Robert, the father of the atomic bomb. Now JT60 SA experiment nuclear fusion reactor. So this was inaugurated in the Japan, a joint initiative of the European and the Japan, EU and Japan. Okay, so these are the forerunner for the under construction of the ITER. Now next one is Kakrapar nuclear power plant. So largest indigenous 700 megawatt Kakrapar power plant that was energizing the recently working with the Gujarat. So India's three-stage nuclear program, that Homi Jahangir Baba advises India's nuclear program in the three stages. So first stage is heavy water reactor fueled by natural uranium, and this fueled fast breeder reactor fueled by the mix of the plutonium natural uranium with sufficient of the thorium. And next is the mixed thorium uranium fuel reactor, thorium transmit into the uranium 233. This achieved the first critically referred to the condition in nuclear reactor operation where the number of the neutron produced by the fission reaction sustain a self-sustaining chain reaction. So fission is a self-sustaining chain reaction. Okay, and this is the fuel and heavy water as a moderator, and we are using fuel and the heavy water as a moderator, fuel and heavy water. In related development, Kakrapar has also recently attained the critically the second and the series of 16 indigenous each of being set up in the country. So there was a 700 megawatt. So related to the uranium enrichment, this according to the IAEA report, the Iran has expected to near weapon grade uranium. Weapon grade uranium is commonly used to enrich about the 90% of uranium 235. Uranium enrichment is a process to create the effective nuclear fuel and increasing the percentage of uranium 235. Uranium found in the natural only 0.7% and chain reaction isotope that was the uranium 235. Naturally, 99% of the uranium exists in the form of uranium 238. Rest in the other isotope that was uranium 235 and 234. That is only 2.7 and 0.6006%. Most nuclear reactors that produce the electricity only require the fuel that is enriched uranium 235. So highly enriched uranium is anything enriched by 20% of the uranium 235. Okay, so uranium 241 that is has been discovered recently, and this is atomic nuclear 92 mass number is 241. It could have a half life of the 40 minutes. New isotope was found during this multi-nuclear transfer. It multi-nuclear transfer is two isotope exchange proton and neutron. Contaminated water stored in the Fukushima Daiichi nuclear power station that was released after the advanced liquid processing system, pumping and the filtration system to remove the radionuclides and the prior to treat it. The contaminated water had the caesium and the strontium, most of the radioactive from the contaminated water. Now, other is the EV and grid charging. The Central Electricity Authority proposed the battery standardization and EV grid charging. This is provide the service to the power system through the smart charging. And there's a smart charging include the bidirectional and reverse charging is also there. It is established under the Electricity Supply 1948 and discharge function under the Electricity Act, which is replaced by the 1948. So this is grid and this is the electrical vehicle, and now this is for the high voltage battery. Fission molybdenum 99. Recently, molybdenum 99 produced located in the Trombay campus of Baba Atomic Energy. Presently, the isotope of the technetium 99. This is short-lived gamma-emitting isotope, and this nuclear medicine it is useful in the nuclear medicine. It can be chemically incorporated into small molecule, and its production begin with the neutron eradication of the fissile U-35. Okay, that is enriched uranium. So fission molybdenum 99 that is located in the Trombay campus. This isotope is for the short-lived and the gamma-emitting isotope, and this can be useful in the nuclear medicine. Okay, now next is direct methanol fuel cell. Alloy of the cobalt and the platinum that is doped the manganese has been found in the effective catalyst in the direct methanol fuel cell. It is electrochemical energy conversion device that is directly convert the liquid methanol chemical energy into the electrical energy. So direct methanol fuel cell that is converting the methanol energy into the chemical energy to the electrical energy. High energy density, high efficiency, low operating temperature, safer for operate, deal with the liquid fuel like methanol. It generates the cleaner energy and can be utilized byproduct as a CO2 and an alternative power source for the small vehicle, battery charging, mobile phones, digital camera, laptop and other small electronic gadgets. So this energy we can use in digital cameras, laptops, small electronic gadgets and the battery charging. So next will be our defense. Next topic will be defense.